0 minus, that is means switch is not closed. Now if we close this switch, this voltage it will go through capacitor also, and capacitor starts to charge. Actually it will initially it will start gradually, it will reach some point, and then it will increase suddenly. Suddenly means voltage across capacitor will be there, and finally this voltage across capacitor, the current in this loop will be 0 when the total voltage that we are giving in the circuit, that should be equal and opposite to the voltage across capacitor C, right? So at the instant of switch, that is before closing, this is the current. Now after we close the switch, right, we are writing I is the charging current across capacitor, Q is the charge across capacitor, right, and right, those two things are okay. And VC, that is the voltage developed across capacitor, right. So first of all you should draw this diagram, and what you have to do is we have to find the voltage across capacitor. So what we have to find the expression for VC, this is the expression that we need, right. If we apply KVL to this circuit, right, KVL is Kirchhoff's voltage law. What it says is sum of voltage rise, that is equal to sum of voltage drop. So in this case, if we apply KVL to this circuit, what we will get is V, that should be equal to voltage drop across R and voltage drop across C. So we can write as voltage across R will be IR, right, and voltage across C I am writing as VC. Okay, now we know I is equal to dq by dt, rate of change of charge, that you can say as current. Again Q in terms of voltage and capacitance, we know Q equal to CV by dt. So in the bracket you can write Q equal to CVC, right. So I can write as C dVC by dt. So I am putting in the first equation this value of I. So we will get V equal to RC dVC by dt plus VC. So this will be the second equation, right. So what I am doing is I am taking VC on the left hand side. So we will get V minus VC, that should be equal to RC dVC by dt. Again in maths you will find this one formula is there, or this method is known as variable separable method. So what I am doing is I am applying that method of variable separable here. So we will get as dVC upon V minus VC, that is equal to 1 upon RC dt, right. Now what I am doing is I am multiplying here by minus on both the sides. So here I will get as minus dVC upon V minus VC, that is equal to minus 1 upon RC dt. So up to now questions are clear, right? Okay. Next what we will do is we will integrate on both sides. So integration will be like minus dVc upon V minus Vc, that should be equal to minus 1 upon Rc dt. So if you remember the formulas of integration, you can write this integration on the left hand side directly as log E V minus Vc, and here you can write as, because there is 1, you can write as minus T upon Rc plus constant K. K is the constant of integration. Now if we have the initial values, we can solve it for K. We can find the values of K. So initial, before the switch is closed, that at t equal to 0 Vc is 0. So I am putting in this equation log E V minus 0, that will be equal to t is 0, you will get as K. Therefore K will be log EV, right? So you can name this as a equation 3, and now putting this value of K in equation 3, we will get log E V minus Vc, that will be equal to minus T upon Rc plus log EV, right? What I am doing is, I am taking this log EV on the left hand side, we will get log E V minus Vc minus log EV, that will be equal to minus T upon Rc. Now we have a simple equation of logarithm, that is log A minus log B. You can write as log A by log B. So I am writing as log E V minus Vc upon V, that is equal to minus T upon Rc, right? Now if we take antilog, or you can write this equation as V minus Vc upon V equal to e raised to minus T by Rc, right? Okay, therefore I am cross multiplying this equation, we will get V minus Vc, that will be equal to V in bracket E minus T upon Rc, right? Or we can write Vc equal to V minus V of e raised to minus T by Rc. I am taking V as common, V 1 minus e raised to minus T by Rc. So this is the desired equation, and this is the expression for voltage across capacitor during charging of the capacitor, right? Here we can write Rc, that is a time constant. We will have the values of resistance and capacitance, that those values will be given in the circuit. We can name it this time constant as tau. So finally we can write Vc, that is voltage across capacitor, will be V 1 minus e raised to minus T by tau. So this is the final equation that we have to derive. Okay, what we have to do is, because the question is asked for 6 marks, what we have to do is, we have to draw a graph also. Graph of, in the x-axis you can take as time, in the y-axis you can take as voltage across capacitor Vc. So in this equation, if you see, this is t equal to 0, right? So if you put t equal to 0 in this equation, you will get as 1 minus of 1, that will be, right? So what you will get as a t equal to 0, e raised to 0 will be 1, right? So final will be 1. So in this equation, what I am doing is Vc equal to V 1 minus e raised to 0, one minus e raised to 0 is, anything raised to 0 is 1, 1 minus 1 will be 0, so it will be this, right? And if you see this e, that is an exponential factor. So if you take for different values of t, you will get a graph something like this, right? So this equation, it shows that this voltage across capacitor follows an exponential law. So you have to draw this graph also. for two, what you have to do is you take different values of t, in the sense 4 to 5 values, and then plot it. Okay. So next question is like question 2c. We'll go through this question first of all. 3 capacitors having capacitances of 10 microfarad, 20 microfarad and 40 microfarad are connected in series to a 400 volt DC source. Okay, and then what you have to do is we have to find the total capacitance first, then second we have to find the total charge in the circuit, third we have to find the total energy stored. Okay, again as I told earlier, whenever you are solving any example, first thing is you have to draw the circuit, and what you have to do is we have to write the what it is given in the question. Okay, so question 2c. Okay, given data, whenever you write in this way, it gives a good impression to the examiner that the student knows and how to proceed for a given example. Okay, so if you see 3 capacitors are connected in series, so this is like my first capacitor, then this is my second capacitor, this is my third capacitor, right, and this is connected across a 400 volt DC source. So I am naming this one as C1, C2, C3, right. So C1, it is given to us as 10 microfarad. C2 is given to us as 20 microfarad. C3, that is given to us as 40 microfarad. Now for solving this question, we should understand what will be the total value of capacitance or the equivalent capacitance when the capacitors are connected in series as well as the capacitors are connected in parallel. So what for series combination we can directly write as 1 upon C equivalent, that is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3, right. So already like the values of C1, C2, C3 are given in the question. We will write C1 as 10 microfarad, C2 as 20 microfarad, C3 as 40 microfarad. It is easy to solve this question, right? What will be? .1. You are having calculator, right? So what you can do is you directly solve it. Right, into 10⁶, that will be common, right? So it will be final, it will be 0.175 into 10⁶. So this will be 1 upon C equivalent. So C equivalent will be you have to reverse it, 1 divided by 0.175 into 10⁶. So what you can do is simply 1 divided by 0.175, that will be 5.71, and the 10⁶, that is in the denominator, it will go to up on the numerator, so it will be 10⁻⁶, or you can write directly as 5.71 microfarad. 10⁻³ is mini, okay, then 10⁻⁶ is microfarad. So normally capacitors are available in nano, micro, all these dimensions are there, all these units are there. So finally the first question that was asked in the first part, the total capacitance, so the total capacitance C equivalent will be 5.71 microfarad. Okay, now the second part of the same question, it is written as total charge in the circuit. The equation of total charge is Q equal to C equivalent into V. Now we have already the values of C equivalent, that is 5.71, right, and V that is given to us, that is 400 volt. So directly multiply, you will get the (5.71) into 10 raised to minus 6 is given. Okay. Right, so it will be (2.28) into 10 raised to minus 3, or you can write 2.28 millicoulomb, or if you want to write this in normally coulomb, the unit of charge is coulomb actually. So if you want to write directly in coulomb, what you can do is divide this 2.28 into 10 raised to 3. (0.0023 coulomb). Right, so the second part again it is okay. Now the third part that is asked to us as total energy stored. Now the equation of total energy that is across capacitor, it will be half C equivalent V square. So half C equivalent, already we have calculated the value of C equivalent, that is 5.71 microfarad. V that is given to us as 400 volt. So if we calculate with the help of calculator, what we will get as 456,800 into 10 raised to minus 6, or divide by 10 raised to 6, it will be 0.4568 joule. The energy, the unit of energy is joule.